In this lesson, we're going to go over how we can use substitution to evaluate integrals. So how can we evaluate an integral such as the one below? So in order to evaluate an indefinite integral, we have been using the reverse power rule. But if we look at what is inside the integral, what is the integrand, we can see that the reverse power rule is not going to work here. There's something more complicated inside, and we're not able to just use that reverse power rule. So this is going to bring us to the substitution rule, or substitution. So what this involves is assigning a function equal to u, and then we're going to be rewriting our integrand in terms of u. So here we can see that we have a function within a function. So our u will be our innermost function, and we're going to rewrite this as f of u du. So what this really is undoing the chain rule. So when we learned how to find the derivative, we learned about the chain rule, which is a function inside a function. So now we have a function inside a function, but we're going to undo it by using substitution. So let's go back to this original problem. So what we're looking for here is the innermost function. So in this case, the innermost function is going to be this 1 plus x squared. And the more we practice doing this, you're going to see how easy it is to kind of identify what u should be. So this is going to be our u. So over here, I'm going to write that u is equal to 1 plus x squared. So if I take the derivative of u with respect to x, right, that's du over dx. So if taking the derivative of u with respect to x, this is going to give me 2x. And we want to find du. So this is what our goal is to find a function evaluated at u and then du. So if we look at what we have a du over dx. So to get du by itself, I need to multiply both sides by dx. So the dx's on this side will cancel out. So I end up with du equals 2x dx. So if we look at what we have everything already set up, right? We have this u, and then we have a 2x dx. Here's a 2x and a dx. So I'm just going to write this a little bit easier to look at. So I have the square root of 1 plus x squared, and then times 2x dx. So I'm just rewriting and reorganizing how this is shown, but still the same exact thing. So now that I know that u is equal to 1 plus x squared, I'm going to rewrite this in terms of u. So this is going to be the square root of u du. So I have the square root of my u function times du. So now that we have it set up like this, we're just going to take the antiderivative in terms of u. So I'm going to rewrite this as u to the 1/2, so I can now use my reverse power rule. So the antiderivative of u to the 1/2, that's going to be 2/3 u to the 3/2, right? Because I'm increasing my 1/2 exponent by 1, so I'm adding 2 halves, which gives me 3 halves. And then I'm dividing 1 by 3 halves, so I get that 2/3. And then we can't forget our plus c. Because this is an indefinite integral and I don't have any limits of integration, I need to make sure that I include that plus c. So we're almost done. We're not quite done. Our final answer needs to be back in terms of what we had. So we don't want to use u anymore. We want to replace u with what we defined it to be. So our final answer would be 2/3. Now instead of u, we're going to put 1 plus x squared back in, and then it's to the 3/2 plus c. So we're getting rid of the x's and replacing them with u's in order to make it simpler so that we can take the antiderivative using what we already know how to do, which is the reverse power rule. And then we're going to plug the expression for u back in at the end. All right, so let's look at another example. Okay, so we have 3x squared sine of x cubed dx. So we want to look for our innermost function. So our innermost function is x cubed. Okay, if you're not sure what your innermost function is, you can pick something to be your innermost function and then take the derivative. And if you don't see the derivative there, then you picked the wrong u. So here, u is x cubed. So my derivative of u with respect to x is going to be 3x squared. And I have a 3x squared, so I know I'm on the right page here. Get rid of the dx by multiplying it to both sides. So the more we do this, I'm going to not show this step. I'm just going to go right to what du equals. But du is going to be 3x squared dx. Okay, so what I'm going to do again is just kind of rewrite this. So I have the sine of x cubed times 3x squared dx. So what this really is, just to kind of make sure we understand this is our u, and this is our du. So when I go to rewrite this, I'm going to have the integral of the sine of u du. Okay, so now that's something a little bit easy that I could take the antiderivative of. So the antiderivative of the sine of u, well, that's going to be negative cosine of u. And then again, it's an indefinite integral, so I'm going to put that plus c. But that's not our final answer because we have to make sure we plug in our x cubed again instead of the u. So we'll have negative cosine of x cubed plus c. Okay, so let's keep going with this. So here, our u, innermost function, is going to be x to the fourth plus 2. Our du, I'm just going to skip that step of doing that dx and multiplying it and just kind of combine it into 1. So my du here is going to be 4x cubed dx. Okay, so I look to see what I have. Now I don't have a 4x cubed dx. I have an x cubed dx, but I don't have a 4x cubed dx. So what I can do is get rid of the 4 by dividing it out. So if I divide this side by 4 and divide this side by 4, right, these 4s will cancel out. So I'll have 1/4 du equals x cubed dx. So now I have what I have on the right-hand side, right? X cubed dx, x cubed dx. So I'm allowed to do that. If I have a number that's not exactly the same, the idea here is that it would be a number, like a constant. If there's a constant that's not there, we can pull it out or multiply it in or do something to make it the same. But we can't do that with variables. So if it didn't have the right amount of x's, if it was like x squared instead of x cubed, we couldn't really manipulate it. All right, so here we've got, let me just rewrite this. We've got the integral of cosine of u, right? The x to the fourth plus 2 is u, times, we have the x cubed dx, so that's going to be 1/4 du. Right, so instead of having cosine of u du, we have cosine of u 1/4 du because we had to divide both sides by 4. So now, what I can do is, because I have this 1/4 that's a constant, our rules of integral says that I can pull out the constant in front. So I'm going to pull out the 1/4. So I have 1/4 times the integral of the cosine of u du. So I'm just going to leave that 1/4 on the outside. And now I'm going to take the antiderivative of the cosine of u du. So that would be sine of u. And then plus c, because it's that indefinite integral. Okay, so last step would be to replace u with what we said it was equal to. So 1/4 sine of x to the fourth plus 2 plus c. And that would be your integral. Okay, so let's look at another one. So here in our function, that's going to be 2x plus 1. That's going to be our u. So du, the derivative of this, would be 2 dx. And we look to see what we have. Well, we have the dx, but we don't have that 2. But that's okay because that's a constant. So I can get rid of it by dividing it on both sides. So I end up with 1/2 du equals dx. So now we have the dx and the dx that matches. Great. So now we're going to rewrite this. We have the integral of the square root of u times 1/2 du. So similar to before, we can take out the 1/2 and bring it to the outside since it's a constant. So 1/2 the integral of the square root of u du. So I'm just going to rewrite this as 1/2 times the integral of u to the 1/2 du. Okay, so that 1/2 is going to stay on the outside because it's that constant, and I'm going to take the antiderivative of u to the 1/2. So we're using that reverse power rule. So we're going to add 1 to the exponent to make it 3/2, and then we're going to divide what's in front, which is 1, by 3/2. So we're going to get 2/3 u to the 3/2, and then we have plus c. Okay, so notice I put the c on the outside. I could put the c on the inside, but 1/2 times a constant c is still going to be some constant c. So we're just going to leave that. So now when I multiply this together, this is just going to give me 1/3 u to the 3/2 plus c. And then again, our last step is to make sure to plug back in our expression for u. So we have 1/3 2x plus 1 to the 3/2 plus c. Okay, so let's look at this one. So this one kind of looks a little bit different. So remember that we can kind of rewrite things to kind of help us out a little bit. So what I'm going to do is rewrite this as 1 over the square root of 1 minus 4x squared times x dx. Right? If I multiply this together, I'm going to end up with the same thing. So I'm just kind of splitting it up a little bit to make it easier to visualize. So my innermost function is going to be 1 minus 4x squared. Right? That's what's in the radical, so that is going to be my u. My du is going to be negative 8x dx. Okay, so we can see that we have an x dx, but we don't have this negative 8. So again, we're going to divide out the negative 8. So we end up with negative 1/8 du equals x dx. So now we have that x dx, which is great. So now we have the integral of 1 over the square root of u times negative 1/8 du. So like before, we'll take out the negative 1/8. That's our constant. And then we have, I'm just going to write this as u to the negative 1/2 du, right, which is the same thing as 1 over the square root of u. And then I'm just going to use the reverse power rule. So I'm going to leave that negative 1/8 on the outside. And then when I do the reverse power rule, I'm going to add 1 to this. I'm going to add 2/2, and I get positive 1/2. And then I'm going to divide 1 by 1/2. So I get 2 u to the 1/2 plus c. So if I simplify this a little bit, this is going to give me negative 1/4 u to the 1/2 plus c. So then again, we want to make sure that we plug back in our u. So this is going to give us negative 1/4. And I'm just going to be fancy here and put a square root instead of to the 1/2 power because it's easy enough to do. This is going to be 1 minus 4x squared and then plus c. Okay, and then we'll just look at one more. So here we have the integral of e to the 5x. So here our innermost function is going to be the 5x. That's going to be our exponent here. So du is going to be 5 dx. When I look at what I have here, I don't have the 5, but I do have the dx. So I can divide by 5 to get dx by itself. So I'll have 1/5 du equals dx. So now we have the integral of e to the u times 1/5 du. So I'll pull out that 1/5. So I have the integral of e to the u du. Antiderivative of e to the u is just going to be e to the u plus c. And then we want to just plug in our u, which is 5x plus c. Okay, so this is the, I guess, real mathematical way of doing this. I talked about it in the other video that you just reverse how you would take the derivative of e to the 5x. So normally we would have, I'm just going to do a little side note over here. So if I had, right, normally what I do if I'm taking the derivative, let's say, of e to the 5x, if I'm asking for the derivative, normally what I do is it would be e to the 5x times the derivative of 5x, which would be 5, right? You multiply it down. When you're doing the integral, you're doing the opposite. So I've had e to the 5x, but then the derivative is 5. So I'm going to do 1 divided by 5. So I'm basically dividing what's in front by 5. So that was kind of the shortcut I talked about last class, but this is the mathematical reason why we were able to do that. It's because we are technically using u substitution.